Hi, and welcome back to the channel. So in our last video, we began our journey into understanding the computer metaverse, and we started with the fundamentals of computer science, which is binary numbers, and how we can use the binary number system to carry out mathematical operations like division and multiplication without the need of times tables as we use in our decimal system. Please, if you didn't watch the last video, you could click here. And it's important to note that these videos are a series with each new episode building on the information of the last video. So with that in mind, in this video we're going to look at how binary numbers combine with logic gates to begin making the magic of computer science happen. So let's As we saw in the last video, we could represent data using binary numbers, the same way we use using the decimal system. But in the binary system, we have just two digits, 0 and 1. But in this case, it's known as bits. Now, in the computer language, when we combine 8 of these bits, we can collectively call them a byte. Just know that 8 bits together make 1 byte. And from there you can group them into larger systems like kilobytes, megabytes, and terabytes, and those are like thousands and millions and billions of bytes. So that's how you store larger data using computer systems in binary system. So this is just a method to represent or store data. And there may be a little confusion when it comes to data, including like megabits and megabyte. There lies a little confusion, gray area, which is a little bit hard to explain. For instance, your internet speed may be shown from your computer in megabytes per second, whereas the downloads are taking place in megabits per second. So you may find your internet speed during a download is indicating to be very slow, whereas it's just showing you the download in another format. So it's a gray area. But that's not the point of this video. With these videos, I just want to provide a framework where anybody can understand or have a basic understanding of what happens within the computer. I'm just trying to make it as easy to understand as possible. So far we have devised a way to represent data or to store data up to megabytes or terabytes, up to any amount. But that's just what we have. What we have now is only a hard drive. If we were to say we have a computer, then the data which we store has to be able to do something. A computer has to be able to compute, do something with the data that it handles. And that is where the topic of this video comes in, which is logic gates. So what are these logic gates and how do they operate? Well, let me start with a real life example. Let's say I presented a rock to you and I just gave you the decision to make any choice of what to do with the rock. So technically, what can you do with this rock? You can either choose this rock or you just leave the rock. So if you choose the rock, that is a representation of the binary bit 1. But if you don't choose the rock, it's like a representation of the bit 0. Now, what happens if I presented 2 rocks for you to make some sort of choices out of these 2 rocks? I'm trying my best to be as simple as possible. Now, if you have 2 rocks, think about that. What can you do with 2 rocks? Technically, you have 3 choices. I'm trying to reduce it to as easy to understand as possible. You have 3 choices. You could either choose one rock and then leave the other one, or you choose both rocks, or you don't choose any rock. Now, these are the set of choices, and with these set of choices, those are the logical options that you have with the data presented in front of you. And well, logic gates work in a similar manner. The way I'm just going to describe logic gates, trying to be the least technical as possible. I'm trying to avoid any technicalities in this explanation. So what are logic gates? The simple definition, a logic gate is a system that can take in some kind of binary input and using some kind of logic makes a decision about what kind of binary output it gives out. That is the simplest definition of a logic gate. So you have your binary numbers or your binary input, and you can feed that into a logic gate, maybe one or two or different. You see the types of logic gates in a moment. You feed the binary input into the logic gates, and the logic gates have some kind of logical system which it uses to understand the binary input and make some decision on what kind of binary output it can give. So now let's just get into the types of logic gates. We have three simple types of logic gates. These three simple types we can combine to form more complex logic gates that can do unbelievable things. All the magic that you see computers do come from just this aspect. So the first logic gate is also known as the AND logic gate, and for a symbol it looks like a D. You have a symbol like a D with some cables or inputs, 2 in and 1 out. So that is an AND logic gate, and what the AND logic gate does is it takes in 2 binary inputs, and it can only give an output if both inputs are true. So again, if you remember, binary numbers come in either zeros or ones, which you can look at them in terms of either true for 1 and 0 for false, or you can look at it as on for 1 or off for 0. And that goes back to the point of me saying, honestly, I'm trying to be as simple as possible. What happens down in the computer, in the micro level, computer circuits and everything, it's difficult to explain. But the AND gate basically takes 2 binary inputs, and if both inputs are on or they are true, it uses those to make an output which is true. So only if both inputs are true, it gives out a true output. Now, when we talk about logic gates, we can represent how the logic gate functions with what is known as a proof table. A proof table just shows us how the inputs react and how we get our outputs, how the inputs vary with the outputs. So for our AND logic gate, let's just make a quick proof table. We said it only gives out an output when both are on. So you have for your inputs and you have for your outputs. So when both are on, you have it on, and for the others, you have off. So you have 4 options here. You have 4 choices, and this logic gate only gives out a 1 when both inputs are 1. Now, please just look at this for a second. Like mathematicians, just look at this in the basic level and try to tell me what this looks like. The AND, like if you have 1 and 0 is 0, if you have 1 and 0 is 0, but if you have 0 and 0 is 0, and if you have 1 and 1 is 1. Now, please tell me what that looks like. Well, it looks like a multiplication table. Like if you were doing a multiplication table, this is how the results are going to be. So this is why in mathematics or Boolean mathematics, the AND operation is also known as multiplication. So in math, sometimes we refer to AND as multiplication. This is the AND logic gate. This is how it works. Then the next we have an OR gate. An OR gate. Now, how is our OR gate different from our AND gate? The OR gate is only different in that it takes 2 binary inputs, but contrary to the AND gate, it gives out a binary output of true if either of the binary inputs are on. So this is a little bit different. So if either of the cables are on, it gives out an output. So as opposed to the first one where it only gives out an output when both are on, this gives out an output if any is on. So that is funny, but you see it goes 0 1 1 0 1 1 1 1 1 0 0 0. So if you look at this, how do you think this is like? It's addition, and this is how addition works. So in mathematics, it's sometimes referred to as addition because as you see here, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1, and 1 plus 1 is 1. But well, you could say 1 plus 1 is weird, but the reason is we're in binary system, so we have just 2 bits, 0 and 1, and 1 plus 1 must be equal to something. So we have to indicate either by like it's equal to 2. So is 2 a 0 or a 1? Like that's the issue. Because we're in binary, we have just two systems. So some people say 0, some people say 1, but this is addition in logic. And also in life or in religion, 1 plus 1 is 1. Anyway, that's what it is. Then the last simple gate we have is also known as a NOT gate. And the NOT gate is really simple. It just flips whatever binary input it has to give the opposite. So whatever input it has, it gives the opposite. So if the binary input was on, it gives an off. And if the binary input was off, it gives an on. If the binary input was true, it gives a false. If the binary input was false, it gives true. So that's how the NOT operation works. And these are your 3 basic logic gates. So now you have your binary numbers, which you can have up to terabytes, and then you have 3 logic gates. So you can store your binary numbers, and using thousands and thousands and millions of these logic gates, you say, hey, you get, if you find this binary digit is 1 and the next one is 1, then please switch it on. And if this switch is on and the next one is off, so you assemble this using logic gates to get all the complexities of a computer. But this is the micro level. Good. So that's where you go. You have the AND, the OR, and the NOT gate. But we don't end it. We can take the NOT gate and put it in front of the AND gate, and now we have a NAND gate. And guess what? This is very important. It's a special kind of choice. Like, let's look at this in terms of choices. The AND choice is like when you choose everything. The OR is if you choose just one, if you have to make a choice of just one. The exclusive OR is if you could choose any of those that you choose. And the exclusive AND is if you have to choose just those that you choose. So it creates boundary within which each decision can be made. And all these logical choices is crucial in programming everything you find in the computer metaverse. So there you have it. Now with our binary numbers and our logic gates, we can get to the next level. So thanks very much for watching. So my name is Azimi, and I'm an environmentalist and sustainability specialist. And the reason I'm making these videos is because I believe we're facing increasing global crisis, environmental issues, including like recycling, sustainability issues, climate change, energy crisis, and a lot of resource management issues. So now more than ever, we need innovative solutions to these issues that we're facing, as they are becoming an existential crisis. So that's the reason why I'm introducing innovation or computer science in a way that it shouldn't be mysterious, or it shouldn't be like magic, something easier to understand, so that by the time we get to where we are building applications, we could understand how to come up with our own basic algorithms for our daily problems to solve them, you know.
Oh my God! Wow!
So these videos are free. You can support the channel on PayPal. You can also support the channel on Patreon. And these videos are free, but they need a lot of resources to put together and to edit and to do a lot of research. But they're free at the end of the day. So help a brother out, support me, help the channel grow. So in the next video, we're going to discover that binary numbers is not enough to make a computer work. Like, of course, we started with binary numbers, but I mean, nobody can code in binary numbers. If we were using binary numbers to code, we would never finish coding a single line of code. So in the next video, we're going to learn about a new number system, the hexadecimal system. And it's interesting. It's a base 16 system. We're going to understand why we need a base 16 system, because it's the system that comes between a binary system and our base 10 system with which we use day to day easily to communicate. So we're going to discover that we're also going to learn about algorithms, we're going to learn about packaging, we're going to learn about compilers, we're going to learn about how hexadecimal assembles the binary code and makes it easier for us to program software, and from there we can then build programming languages which build upon the knowledge of this. So upon that we will then get to algorithms and so on and so forth. So thanks very much for watching. Let me get now onto the next video while I will catch you there. Thanks very much for watching. Ciao.